in this lesson, we're going to be looking at volume of prisms. So obviously a couple of key concepts that you'll need to understand are the idea of what volume represents and what we're talking about when we refer to a prism. So with volume, volume is going to be something that we measure with three-dimensional figures, because with volume we're talking about filling something up. So if you think back to the measurements that we've done, we've had one-dimensional measurements. That would be things like length, width, perimeter, circumference, diameter, just straight measurements, one-dimensional. We've had two-dimensional measurements. That would be area, where you're measuring things in square units, so you're covering something with squares. With volume, we're talking about a three-dimensional measurement where you're filling something with cubes, so it will be measured in cubic units. For example, we can measure volume in cubic centimeters. And if you remember, with square centimeters or square meters, whatever the case may be, we represented that with an exponent of 2. So with cubic centimeters, you can see right there, we're going to represent that with an exponent of 3, because we're talking about three dimensions, length, width, and height, or you might call it length, width, and depth, whichever one you want to use. So when we're talking about volume, you can only find volume of three-dimensional shapes. It's the measure of how much space is occupied by that shape, or you can think about how much space is inside, what it would take to fill it up. It's measured in cubic units because we're filling with cubes. Okay, so this is just a kind of a good picture of what we're talking about when we look at volume. So if you look at this three-dimensional figure, okay, this is a rectangular prism. The way that we know that it's a prism is because it has congruent and parallel bases at both ends. With a rectangular prism, it really doesn't matter which one you choose as the base. It doesn't have to be the one that it's sitting on. It just needs to be two rectangles that are congruent and parallel. So I could choose, for example, I could choose the front of this rectangular prism and the back of the rectangular prism. And I could call those my bases, or I could use the left and right or the top and the bottom. It doesn't matter. But if we look at this picture of the rectangular prism, you can see that we have like a layer of cubes on the bottom. So we have a 4 by 3 layer of cubes. But in order to fill that rectangular prism, we would have to have 2 layers. Well, a 4 by 3, that's going to be 12 cubes. So that initial layer of cubes, there's 12 cubes. But if I do another layer, so I stack a second layer of 12, that's going to be 24 cubes. So it takes 24 cubes to fill that box or that rectangular prism. So we say the volume is 24 cubic meters. But obviously that would not be a very efficient way to find volume if you had to fill everything with cubes and then count the cubes. So there is a formula that you can use, but that's just sort of a good picture of exactly what we're doing when we measure volume. So with rectangular prisms, that's a three-dimensional shape that has 2 parallel and congruent sides, or we can call those bases. Okay, 2 parallel and congruent bases that are rectangles. And then you also have 4 rectangular faces. So there's a difference. Bases are faces. That'll get maybe a little bit confusing because they rhyme, but the bases are faces, but you're only going to have 2 faces that count as bases, and then you'll have 4 rectangular faces that connect those 2 bases. Almost sounds like a Dr. Seuss book. So to determine the volume of a rectangular prism, what we're going to do is multiply the area of the base. I want you to look very carefully at this formula where you see this capital B. Do not get in the habit of seeing that capital B and reading it as base. Capital B means area of the base, and that is hugely important. In fact, right now, why don't you pause the video and say to yourself 5 times, capital B means area of the base. Go ahead and pause the video and say, capital B means area of the base. Capital B means area of the base. Because that is hugely, hugely important. So just say that over and over to yourself so that it will stick. Okay, welcome back. So hopefully you have that down, that capital B means area of the base. Now, lots of students come to 7th grade and know this formula. In fact, sometimes I'll ask, what is volume? And students will say, oh, that's length times width times height. No, volume is how much space is inside. Length times width times height is just a formula to find the volume of a rectangular prism. But this formula will work for any prism. So if you can just learn this one, area of the base times the height, then you can find the volume of any prism. This formula over here only works for a rectangular prism, because if you look at that length times the width part, that's how you find the area of a rectangle, and a rectangular prism has a rectangular base. So what you're really doing is finding the area of the base and then multiplying it by the height of the prism. So that capital B means area of the base, and then this H is talking about the prism height. And the best way to explain that is that it's the distance from base to base. So identify your two bases, and the distance between those two bases will be your height. That won't always be a vertical distance or a straight up and down distance. Sometimes we think, okay, it's height, it's got to be straight up and down. Nope, it might be horizontal, might be left and right if you've put your two bases at the left and the right. So just remember that your prism height is the distance from base to base. Okay, and again, it's written out over here. Okay, this is truly important for you to understand that when you see capital B in that formula, it's referring to the area of the base. So if you look at this rectangular prism, okay, and again, if you look at the example in the notes, they've used length times width times height. I would much prefer you, I mean, that's going to work, but only for a rectangular prism. I would much prefer you to see that and go, okay, that's a prism. So volume is equal to area of the base times the height. Now let's identify our base shape. Again, on a rectangular prism, it's always going to be a rectangle, so it really doesn't matter which two rectangles I use as long as they are parallel, right across from each other. So let's just say we use the top and the bottom. So I'm going to say, oops, let me get a better color. So we'll identify that as a base and that as a base. Okay, so we're saying that that bottom is a base and that top is a base. Now we could have used the left and the right or the front and the back. It doesn't matter as long as it's two congruent and parallel rectangles. So remember, capital B means area of the base. So we just identified the base as a rectangle. The formula for the area of a rectangle is length times the width. Then we're going to multiply that times the height of the prism. So let's identify that. Height of the prism is the distance from base to base. So in this case, that's this distance right here. That's the height. Okay, so our base is a 6 by 5 rectangle. So 6 times 5 will get us the area of the base. Times the height, the distance from base to base is 8. So we can say 6 times 5 is 30. And 30 times 8 is 240. So the volume of that rectangular prism is 240 cubic inches. Okay, so look at this one. So let's identify our base.
Teachers, pardon this interruption just real quick.
Okay, sorry about that interruption. So let's identify our bases. On this one, let's go ahead and say the front and the back are our bases. Okay, it really doesn't matter. We're going to say the front and the back are our bases. So the area of our base, remember, volume is equal to area of the base times the height of the prism. Well, our base is a 7 by 3 rectangle. So the area of our base is 21 square meters. Okay, height is going to be the distance from base to base. If we did the front and the back as our bases, this is the distance between them. So our prism height is 4 meters. So then we're just going to multiply that. Area of the base times the height. So 21 times 4. And we get 84. So the volume of that rectangular prism is 84 cubic meters. Look at this next one. Okay, on this one, let's do the left and right as the base. So let's say that these two sides are our bases. Okay, if we're going to find the volume, again, the volume of a prism is area of the base times the height. Our bases are 2.7 by 2. So 2 7/10 times 2. Okay, that's how big those two rectangles are. That's their dimensions, 2.7 times 2. Okay, so the area of the base is 5 4/10 square feet. I've got to multiply that by the prism height, which is the distance from base to base. So that's this distance right here. That's 3 feet. And so at that point, then I simply multiply the area of the base times the height. So 5 4/10 times 3. And we get 16 2/10 cubic feet is our volume. Okay, now those were rectangular prisms. Let's look at triangular prisms. Now, I can tell you the biggest mistake right now is lots of people will look at that right there and say that's the base because that's what it's sitting on. What it's sitting on has nothing to do with it. This is called a triangular prism because its bases are the two triangles. So in this case, volume still equals area of the base times the height, but in this case, our bases are triangles. So remember, to find the area of a triangle, we do 1/2 base times height. So in this case, that's 1/2 8 times 5. Half of 8 is 4, so 4 times 5, and that's 20. So the area of our base is 20 square millimeters. Your height is the distance from base to base. So you're talking about this distance right here, and that's 12 millimeters. So to get the volume, our area of the base was 20, our height was 12. So we'll do 20 times 12 and get 240. So the volume of that triangular prism is 240 cubic millimeters. Okay? Now if you look at that triangular prism, it's easy to recognize. Triangular prisms have 2 parallel and congruent triangular bases and then 3 rectangular faces. That is not a rectangular prism. It's got 3 rectangular faces, but we name prisms by their bases. So since those bases are triangles, that's a triangular prism. Okay, next one, same thing. This is a triangular prism. So our bases are these 2 triangles. Okay, volume is area of the base times the height. Our bases are triangles. The way you find the area of a triangle is 1/2 base times height. Okay, it's very important here that you notice that that right angle mark is right there so that you know what to use as your base and height of the triangle. So we're going to have 1/2 8 times 15. Okay, this 17 is not needed. Okay, that is not a base or a height. With a triangle, your base and height must form a right angle. Okay, half of 8 is 4. And then we have 4 times 15. And that is 60. So the area of our base is 60 square yards. Your height is the distance from base to base. So that's going to be this distance right here. That's your height. And that is 11 yards. So to get your volume, we just do 11 times 60. So we get 660. So the volume of that triangular prism is 660 cubic yards. Okay, that's it for finding volume. The key really is just recognizing that you have to find the area of the base and then multiply that times the prism height. Okay, those are the key things. Go ahead and circle the icon that best describes your confidence level in finding the volume of a rectangular prism and a triangular prism. And that is it for lesson 7-6. Have a splendid day.